Washington State University. Go Cougs!
Welcome back to the course on behavior analysis from ambient sensor data. In this course, we have been looking at ways to analyze human behavior based on sensor values that are collected in everyday environment settings. So far, we have shown an example of a smart home that is equipped with ambient sensors and have described the function of the sensors that can be installed in an environment such as this home. We have discussed how to collect data from these ambient sensors, to assign timestamps and sensor identifiers to each one of the sensor readings, and to store the readings or sensor events in a database for later analysis. In this course segment, we will look at how to learn activity models from the data that is collected by these ambient sensors. The focus of the course is observing and analyzing human behavior. Activities give us a vocabulary to describe these behaviors that are observed by ambient sensors. Once we identify activities and recognize their occurrences in everyday settings, then we can use this information to understand human behavior and to analyze the relationship between human activities and other parameters of interest, such as health status, consumption of resources such as electricity or water, indoor air quality and how it is impacted by behavior, and the security of a home or other physical environment. Learning and modeling activities also provide a basis for designing activity-aware services, such as home automation, health intervention, and automatically contacting emergency service providers. In this course segment, we will introduce several techniques for analyzing sensor data in order to recognize, to discover, and to predict occurrences of activities. We will start by describing techniques for accessing these features that provide contextual information from the sensor data, and then we'll describe methods of mapping such a vector of feature values to an activity label or performing activity recognition. Next, we will introduce ways of automatically discovering activity patterns, and lastly, we'll introduce methods for forecasting future occurrences of targeted activities or performing activity prediction. Let's first take a look at what the data looks like when it comes from a smart home filled with ambient sensors as a resident performs a normal daily activity. The video on the right of the slide will show a resident entering a smart apartment where she will perform a sequence of activities. After entering the home, which is one activity, she will next start to put away groceries that she brought home with her from the store, another activity. In the upper left area of the screen over here, we will see sensor events as they are generated by the ambient sensors in the home. By a sensor event, we mean a text message with information that is sent by a particular sensor. Each of the sensors in a home such as this one are discrete event sensors, so they only send a sensory event as a text message whenever there is a change in their state. For motion sensors, this means when there's a change from no movement to new movement, or a change from movement to a stopping of movement. In the case of light sensors or temperature sensors, they will send a text message whenever there's a significant change in the sensed light value or temperature value. And for door sensors, they will send a message whenever the door is opened or closed. We will see events one at a time up here in the upper left as these messages are generated during the activities. Each sensor event includes the date that the event occurred, the time, the identifier of the sensor, and the corresponding sensor reading or message. The first letter of the sensor identifier will indicate what kind of sensor is generating the message. If it begins with the letter M, then that is a motion sensor. If it begins with a D, then the corresponding message is generated by a door sensor. An L or LS sensor, as we see here, is a light sensor, and a message starting with a T indicates a temperature sensor. Down here in the bottom left is a visualization of the apartment that the resident is about to enter. There are 2 floors to the apartment. The left half here is the upstairs, and the right half is the downstairs where the resident will enter through the door at the bottom. As she performs activities in the space, you'll see different icons change color, corresponding to a change in state for the sensor. These circle icons each represent a different motion sensor that is observing the area right around this circle. The rectangles, which may be green or transparent, are door sensors, and the numbers are light sensors. So in the case of motion sensors, when movement is detected, they will turn red and become transparent when movement stops. Door sensors will turn green when the door opens and become transparent when it closes again, and numbers will change as the light levels change. We should see these changes at the same time that sensor messages appear up here in the upper left, and as the resident moves through the space. We can see the resident entering the home and the door opened. Similarly up here, there's a sensor event starting with D001 that says open. Then we see a variety of motion sensor and light sensor readings as the resident moves through the entryway to the kitchen, then putting away groceries. She opens up a cabinet door, as we see in the visualization down here, continues to move through the space, putting away groceries, and causing motion sensors to turn on, then off, depending on where she's at in the space. There's even motion sensors in the refrigerator, so when the resident opens the refrigerator to put groceries there, we can see that she's accessing that area. And finally, she moves into the living room in order to start another activity. The goal of activity learning is to be able to make sense of the sensor data that's collected as a resident performs normal daily routines like we see here. We want to be able to automatically recognize the activities that the resident is performing, to automatically discover activity patterns. And once we're able to identify activities of interest, then we want to be able to forecast or predict the next time that these activities will occur. We will look at these topics in the upcoming videos.